This is the second substitution question. So if you haven't already watched the second substitution video, so if you haven't already watched the first one, you need to. Okay, so I'm going to do a little bit of a harder substitution question. The reason why this question is a little bit harder is because the derivative is not just easily available. I have to do some manipulating first. Hopefully you'll see what I mean. So first of all, I look and I say, okay, is this a substitution question? Do I have a function all to the power? Which I do. I have 1 minus x cubed to the power of negative a half. So then do I have the derivative of the inside hanging around? Well, I have the derivative of the inside is 3x squared. So I have minus 3x squared. So I have the x squared part, but I don't have the 3 part. That's okay. I can manipulate to make it work so that I end up with the 3 part, and you're going to see how that's going to happen. Having said that, if I was missing the x squared part, I cannot manipulate for the x squared. Okay, so it's super important. When I ask you to have the derivative hanging around, it's okay if you don't have the coefficient that you need, but you need the variable with the correct exponent. I hope that makes sense. So let's go ahead and try this question. So first of all, let's just rewrite this question like x squared times 1 minus x cubed to the negative a half dx. So u is 1 minus x cubed. So fu is u to the half, okay? So my next step is to do du dx. So du dx is negative 3x squared, okay? So then I've accommodated for this part here with the u to the half. So I need to rearrange this so it's x squared dx because I need to substitute in for that. So I need this to equal x squared dx. So I'm going to start by multiplying both sides by dx. Well, now I have this minus 3, which is annoying. So I'm actually going to divide both sides by minus 3. So I end up with du over negative 3 equals x squared dx. So that's perfect. I've rearranged. That is going to be substituted instead of this. Okay? So I'm going to go ahead and do that substitution. So I end up with u to the half times du over negative 3. Okay? This isn't time, sorry. So I don't like him. He's annoying. I don't want to find the integral with him involved. So what I'm going to do is I'm going to take him on the outside. Because if you remember from the first video, I can move coefficients in and outside of my integral sign. So what I am actually going to do is move this over so you guys can actually see what's going to happen next. Okay, I'm going to go up here and I'm going to take this guy outside. So I'm going to write him like minus a third integral u to the half du. Okay? So all I did was move him on the outside, which is totally allowed. Now I feel good about finding the integral of this. So I add 1 to the exponent and divide by the new exponent. Oh, this is negative a half, sorry. This is negative a half. This is negative a half. Okay, so I add 1 to the exponent and I divide by the new exponent. So dividing by a half is the same thing as multiplying by 2. So there's going to be a 2 in front of here, plus c. So I end up with negative 2 over 3 u to the half plus c, and then I just need to plug in for u. And I don't care if you write u as a half or a square root, it doesn't matter. And you're done. Okay? So the reason why this problem was a little bit harder was because I didn't have the 3 that I needed to make the derivative of the inside function, but did you see how I manipulated that 3? You are allowed to move numbers in and outside of your integral sign. You are not allowed to move variables. So this, I could not write like this. Not allowed. Bad. Okay? Don't do that.